We're going to keep working now on stoichiometry and mole ratios. And the new twist here is that we will be looking at solution stoichiometry because that's the chapter that we're in. So to do this, we just want to have a bunch of the same tools we've been using all along. We like to use molar masses because that lets us measure grams and count moles. We like to use mole ratios. And if you remember mole ratios, those are going to be moles of A over moles of B, and those come from the coefficient. So those are the numbers we've been using to count substances in a reaction all semester. We also saw last chapter that we can use the ideal gas law. So that would be PV equals nRT. And a new thing for this chapter is to use molarity, which is moles over liters. You'll notice that there's moles in all of these. And because there's moles in all of these, they relate back to the mole ratios that you see in the equation, and that's why they're good for stoichiometry. One last bonus conversion that you can use also, which we won't be using in this chapter, but it's a good one to know, is we can use density. Density is grams over milliliters, and this is especially good if you have a liquid, and maybe it's easier to measure volume than mass or mass than volume, then you can use this as a conversion as well. So just to get a glimpse of how all these pieces would go together, especially for things where you have solids. Solids, it's very easy to measure them in grams, and then you can convert those to moles, right, by using molar mass. So we can do that. We're very familiar with that back from chapter 6. Also for aqueous solutions, we've done grams and moles as well. And we can go back and forth between all of those. For gases, sometimes we've done moles and grams as well. And liquids, we've done grams and moles as well. You get the picture. We can use molar mass for everything, right? So we can do moles and grams for all of these, or I could just be in moles and then work my way there. Notice everything we have has to convert to moles, and then we're able to use those coefficients. So what if we have a gas? This is what we learned last chapter. If we have a gas and we can get to moles, then we can use our ideal gas law and maybe figure out instead what the liters of gas are. So that's a good little addition to our scheme here. And then I told you today that we're going to work on solutions, right? And so solutions have this volume in them. And so if I have something that's aqueous here and say I get to moles, I can work out to liters of solution using molarity. Or here's another aqueous substance. So if it's aqueous, then when I get to moles, I can work back and forth to liters using molarity. So basically, we can work 20 different types of problems here just using this one balanced equation and some of these conversions here. A place where you might use this density would be over here if I have a liquid and say I have it in grams and instead I want to use milliliters, then that would be a good place to use your density to switch between mils and grams and then get your way over to moles. So if you can grasp all the connections here, you can do just about any problem that we've done all semester. So next up, we'll see how to use this, specifically focusing on a couple of these liter problems.